Hello everybody, this is a presentation on the Beck offshoot product from the super oscillator. I've taken various aspects of the super oscillator and incorporated them into single function packaging designs, and here is one of them. I've got the case open presently. It's got a lithium ion battery in there. Get a little closer. 550 milliamps. Once it's closed up, it can be recharged with the universal power supply. I'll show that also. And you should never have to open it up again. I only have it opened so you can see the internals for those who are interested and sort of geeky. It's got two circuit boards. If I remove the battery here, you can see another circuit board, and it's mounted, it's upside down. That's a trim pot that you're looking at, blue pot there. And that trim pot is used to adjust the 9 volts up to 29 volts. That's 9 to 29, not quite 30. And there's a differential op amp, or an op amp, being used in a differential mode of operation, and the net is that you'll get a 55 volt peak to peak non-polarized pulse. Non-polarized meaning that it's not referenced to ground, it's just referenced to itself. It floats. I presently have a stereo plug plugged into it. I'm only using the tip and the base of the stereo plug because there's only 2 wires connected to the output plug here, or jack. It has a current control pot. Turn it on the side. There's an LED here that you can see through a pinhole on the case, and it's buried inside. You have to look right at it to see the LED, and that's done so it's not a disturbing flashing light if you're using this device and you're lying down and it's sort of dark, or you have something that you're watching and you don't want this LED flashing at you all the time, so you can see it. The lithium-ion battery, as I read from the spec sheet, said it was capable of 1,000 recharges. That has yet to remain to be proven. I haven't done 1,000 recharges on this battery. It's a unique battery with respect, you can't overcharge it. What happens when it finally reaches charge, there's a, I believe it's a thermal bimetal strip in there that actually turns the battery off if it starts to warm up. It's probably a safety device to stop the battery from blowing up, which works out real nice because my universal charger doesn't know when to stop, although it does have a display on it so you can see what the voltage level is, and you can just unplug it, and it's only a 200 milliamp charger. It can't overcharge this lithium-ion battery, which is sort of a nice feature. Them working, working hand in hand. The current draw on this is about 25 to 26 milliamps. So with a 550 milliamp lithium-ion battery, you can do the numbers and figure out how long it will actually run. I'm guesstimating that you could probably run it very nicely for about 10 hours between charging. You might be able to get a lot more out of it than that. 5,500 milliamps. Lithium-ion batteries have a habit of dying quickly. In other words, they'll maintain their voltage level pretty close to, in this case, 8.4. That's what the battery output is. It's 8.4 fully charged, and it'll stay 8.4 until it really starts getting close to being discharged. So at 550 milliamps, that's milliampere hours. You've got, let's see, 25 goes into 500, 4 times 5, 20 hours. I don't think it's going to run that long. Time will tell. You can test it and tell me what you find if you happen to either build one yourself or order one that I will make available. So here we go. I'm going to close the cover up. And I'll finish describing the unit. Cover just slips right on. There you go. And I will put 4 screws in here. And I'm just screwing it on, closed. In theory, I have no reason to ever go back inside here. I only wanted to open it up so I could show those interested what was inside, what's it look like, how it's built, how neatly it's wired. It's wired very clean. Okay, it's closed up. And on the outside you can see a little pinhole over here. That's where the LED light is. Let me turn it on, and it's flashing. And you can see that little flash if I get the angle right in the camera. Had it a couple of times. Come on, camera, show me the flash. All right, between the camera syncing and the scan rate and the LED flashing, it's really a nice solid flash. It's pulsing at 4 hertz per second. And you have to look right at it to see it. The pot for adjusting the current level. The output jack right here, the output jack. On the other side, the on-off switch, the little white slips on and off. And then the recharging adapter, power adapter. And that's the unit. It's 3 1/4 inches tall, 2 inches wide, and it's 1.25 inches high. Maybe a smidgen over, maybe more like 1 3/8 inches high. Very tiny box. I have small hands. You can see how it fits in my hand. Easily will strap onto the arm. Just it's a whole bunch of things you can do with it, or I can do with it. And that is the Bob Beck device that I built from the super oscillator. There's plans down the road to make it dual frequency, 4 hertz and 7.83, which would be the Schillman's resonant frequency, one of my favorite frequencies. But I have no input, or there isn't much input or any input on the pulsing rate of 7.83 and whether it will clean out pathogens in the blood or whatever. Who knows, because that's Mother Earth's resonant frequency. Maybe it'll promote life forms to grow in your blood. All right, so much for that. Let's demonstrate the unit by turning it on, plugging in something I can actually measure with the scope or see with the scope. Minus to minus, so I call it minus. Like I said, it's non-polar. And there you go. You probably can see the square wave. Between the syncing of the camera and the low frequency, it looks not quite as good on the camera image as it does to me personally. I can slow it down so you can sort of see it going up and down. And that is a 4 hertz square wave pulse. And if I had this mounted, or if I was using it, I could control the current delivery with this pot right here. It's all black and the pot knob is black, so it's hard to see it, but I think you can see it. I'm pointing to it right there. Alright, so the next thing to do is to show you how you charge it with the universal power supply. Rather interesting little device. It's put in a pill container and it has a display. And it will charge 9 to 12 volt batteries. And if I open it up and take out the plug and close it back up, you don't have to, you can leave the plug outside and there it is. So I could plug in a 9 volt battery directly, or in the case of charging the internal battery in the Bob Beck device, I can plug on this little adapter that I made. Hopefully you can see it. You'll see me plug it together. It's plugged together. It's got a standard power, goes in. Now you can't run the Bob Beck device off of AC. As soon as you plug in the power plug, turning on the on and off switch it's disabled. And this was done so there was no way that this device could be run off of AC from a wall outlet and that you could get bit by something shorting or whatever AC wise. So I'm plugging in my little Vampire module, wall module. This happens to be a 9 volt 200 milliamp DC module. I must have a dozen of these floating around. You can pick them up at Radio Shack. They're just real cheap. $5, $6, whatever. 200 milliamps. Center terminal positive. On a scope it measures about 12.5. As a matter of fact, before we connect it up, let's just see what. Okay, so the display saying that 12.5 volts coming in to the charger. Plug the charger in and it'll tell me the present level of the batteries. The present level of batteries is 8.11 and climbing. It'll go up to 1.2, 1.3. Now lithium ion batteries will only charge to a 9 volter will only charge to 8.4 volts. The nice thing about a lithium ion, it's almost a constant current forever until it just dies. So it stays close to 8 volts its whole lifetime of operation. It doesn't drop down to 8.5 or not even 8.5, 7.5, 7, 6.5 and slowly degrade. It stays at roughly 8 volts and then when it gets near depletion drops rather dramatically, quickly. So that is the universal charger charging the Bob Beck device. I call it a universal charger because I happen to have a different snap device that I made up, a different snap with a couple of alligator clips. And if I plug this one on, right here, I have a 12 volt battery that I charge with this also. It trickle charges the battery. And if I switch from this little module to a 12 volt unit, a 12 volt Vampire plug wall module, it'll certainly bring the 12 volt battery up to a level of about 13.6, 13.7 easily. At overtime, of course, it's trickle charging at the rate of maximum 200 milliamps per hour, ampere hours, 200 milliamp hours. And that's my universal charger. Now I'm in the process of building some other devices that are much more sophisticated with on-off controls. They'll have to fit into a bigger pill case. But this is pretty handy, pretty compact, and I'm not sure that I'll market a 12 volt adapter. Most geeks and most people can make one themselves, but we'll see how we put this all together. So that's the end of my presentation. I hope you enjoyed it, and check my website out, aurorasky.net, and see what we have to offer. Bye-bye.